Hi there and welcome to today's class. We'll proceed in solving several problems involved in the study of hydraulics and hydrology. We have done a good number of past questions on this course. We'll proceed by solving several other problems in the study of hydraulics and hydrology. The question attached to this diagram says the cross-section of an open channel is a trapezium with a bottom width B of 3.6 meter and side slope of 1 vertical to 2 horizontal. Assuming that C is the Chezy formula is 49 SI units, what will be the discharge Q if the depth of water D is 1.2 meter and the slope S naught of the bed is 1 in 1600? First is first. In science, after reading that question, your next priority there is to list out the given parameters. All right, given there. So first, it says a cross section of an open channel is a trapezium. Of course, the diagram in quotes attached to this question is shown on the board here. So this is like a trapezium, but what? Then an open trapezium. Of course, this part here is not closed; it's open. So this man becomes an open channel trapezium with a bottom width of. So I'm given first. I'm given bottom width. That's width. So the width there, that's B. Of course, the value gives 3.6 meters. Next up, it says and side slope of 1 vertical, 2 horizontal. So side slope, the side slope is given as 1 vertical and then 2 horizontal. Next up, it says assuming that C, by the way, C is Chezy formula. So C there, the Chezy formula, that C is given by 49 SI units. Proceeding, it says what will be the discharge Q. So I'm looking for Q. So discharge there is unknown. Discharge in brackets Q, of course, is unknown. Next up, it says if the depth of water, that's D, depth is given, depth in bracket D of water to be 1.2 meter, 1.2 meters, and this slope, that's S naught. So S naught is given, slope S naught, that's bed slope, is given as 1 in 1600. Now these are what is given. So with this concept here, I'll start solving. So my priority or my first important idea here is that I am looking for discharge, just Q, right? So first, what do we know? From here, first, I would like to convert some stuff. Now my breadth and depth are in meters, no problem. Next priority is that we said S naught is always in fraction form. So, or perhaps from here now, S naught is always in fraction form. So this S naught here gives you 1 vertical and what? Sorry, 1 in 600, 1600. So that becomes 1 over 1600. Divide this one, what do I have here? If I divide 1 by 1600 there, I will have about, hold on, if I divide 1 by 1600, 1 divided by 1600, this man gives me around, let's say, 0.000625. All right, so the value of S naught is now this. Next task, that's all basically. So I'm good to go with these parameters here. So first, I'm asked to find this charge Q. What do we know? To get this charge, recall that in order to find this charge Q, what do we know? We know that Q is equal to what? The area times velocity. So here's the idea and technique. I want to get Q. I need two things. What and what there? I need area and I need velocity. My first priority is to get area, and but listen please. But this V here, velocity. In this velocity here, there's one parameter called R. R there is called the hydraulic radius, right? So my first priority now is that to save time and stress, let me rather go for looking for C first. So looking for V first. So on the place of getting V, I'll get area at long run. So the task now is that I need to get out the value of A under this concept, right? So let's get V first. So calculate velocity. First task, calculating for the velocity or the mean velocity in brackets V. What do we know? Recall that we said V, or perhaps mean velocity, is equal to C root R S naught. Alright, I have this one here. Alright, so get V easily, I need three things. What and what? I need C. Of course, C is given as 49. I need R. R is called the hydraulic radius. It's not given yet. I need S naught. So S naught is given as 0.000625. So our first priority now is to get the value of R. So calculating for R. So calculating for hydraulic radius in bracket R. What do we know? We said R is equal to the ratio of the weighted area over weighted perimeter. All right, I have this place. Weighted area over weighted perimeter. So this idea, I need to get area and perimeter of this trapezium so as to get the hydraulic radius. So let's get the area of this shape is. So calculate for area. Calculating for the area in bracket A. What do we know? First, the area here, for this condition here, the area for this condition here is given by, of course, the area for this condition here is given by half into 2b plus 4d in bracket d. All right. So this is like the area. When it comes to this trapezium concept, the area there is given by half 2b plus 4d plus d. How do I come up about this formula here? First things first. We said from here to here is simply your depth. What do we know initially? Area of a trapezium itself is given by half into A plus B, then H, right? This is like the area of a trapezium here. So I related this area of the trapezium with this. This half is this half here. So all this height here is the deep here. That's your height, depth. That's it here. So this A plus B, I don't that give us 2D plus 4D. So how do I get this value here? I got this value by, if I take this part up here a little bit, take this part here up a little bit, from here to here is your breadth. So it means here to here gives you a breadth, right? So here's the idea now. This part here becomes 2D. All right. This part here becomes a 2D. All right. I have this place. So if here to here is breadth, so this part becomes twice depth and twice depth. So to get the area of this figure diagram, that becomes your half. Then the A there signifies the breadth. So I have 1B, B plus B gives you 2B. I have 2B here, plus this plus here is this plus. The B here in this case becomes your 2D plus 2D. That gives you the 4D. Then the H here signifies the depth. Work on this place. This gives you work on this here. This gives you about area equal to half. Work on this here. This gives you area equal to half into 2 into what's B? Of course, B is 3.6. 3.6. Let me use a square bracket. All right, 3.6 plus 4 into what's D there? D. That's 1.2. 1.2. All right, I have this man. What's D here? Of course, 1.2. 1.2. Let's get A. All right, let's get A. Let's get A. From here, area here gives you area is equal to half into 2 times 2 multiplied by 3.6. That gives 7.2 plus 4 times 1.2. That gives about 4.8. Of course, I have my depth there, 1.2. This gives you area equal to 1 over 2 into, add up this one, gives you 12 into 1.2. From here, area is equal to 2 here 1, 2 here 6. 6 times 1.2, that gives about 7.2 meter square. Of course, I have gotten the area. Next part is to get the perimeter. All right, let's get perimeter. Calculating for the perimeter of the open channel, that's P. So perimeter P. Now here's the idea. To get perimeter of shape, the idea is simply just add all the sides together. So it means I'm adding all the sides together. So I'm adding year to year 3.6. I'm adding it with year to year and then year to year. If you observe, this part to this part and this part to this part is not given as a value. So I need to get what would be the value of this line and the value of this line. How do I do that? It's easy as we said, check if you check your parameter when we're given one vertical and then two horizontal, right? One vertical, check very well. They give us a part that says one vertical and two, that's um coming side slope. Yes, they give us side slope. One vertical, two horizontal there is idea we're going to be using here. So I have one vertical, two horizontal. Of course, from here, this is one vertical, two horizontal, right? This part here gives you one vertical, two horizontal, right? So this one here will take, because I'm trying to get this line here, this long line here. So I'm saying this line here, coincide with this triangle here I drew. So I want to use the idea of Pythagoras theorem to get what value with this line B and this line B, using the concept of one vertical and then two horizontal. So let me call this line here that I want to get, let me call it line Z, right? Let me call the line I want to get, let me call it line Z, right? So from here, what do I get? Okay, from here. First is first, I'll draw this shape. Perhaps I'll draw the shape this way. This way. Now, here's the idea. I'm trying to get this long part. That's Z. Let me call it Z. Right. Next up is that we know that from here to here is the vertical part, Abi, and which signifies the depth. That's D. So I have D here. Of course, we said this part here consigned with this part here, that's 2D. So I have 2D as this case. So with this one here, I will apply the concept of Pythagoras theorem to get Z here. So using Pythagoras theorem, that gives you Z square is equal to the square sum of the two other sides, right? So I'll take this part off. I'll take this part off. So from here, this gives you z square is equal to d square plus 2d all square. In fact, in this form. All right, I have this place. Work on this. This gives you z all square is equal to, what's d? Of course, d is the depth, 1.2. That gives you perhaps, okay, before then I still have my d square remaining, plus this one gives you 4d square. If I apply indices, the power here will affect, two. That gives 2 to power 2 gives you 4. D to power 2 gives you d square. Work on this one here. This gives you about, this gives z in bracket square is equal to d. Of course, d is 1.2. My depth there. Okay, of course, from here I have d square plus d square. The number front of here is 1, so I can say d square plus 4d square gives you 5d squared, right? This gives you z square is equal to 5 into what's d? 1.2. 1.2 all squared. Work on this one here. Z squared gives you about, multiply this together, you have 7.2, right? So 30 square here becomes a square root. That gives you z equal to the square root of 7.2. Of course, z in this case is equal to 2.68. It means that from here to here is 2.68 to 2.68. From here to here is, of course, 2.68. So we want to get the perimeter. Perimeter is easy as add all the sides together. So I'm adding 3.6 with 2.68 with what? With this 2.68. That's the perimeter solution. All right. Work on this. Work on this. So moving on here, for the perimeter here, we said P now will be equal to, as simple as I'm adding this B, so that becomes B plus this Z part here, Z plus, of course, I have under Z. I can call it whatever. You can call your own A or B. So I just choose to use Z here, as in this case, right? So work on this. This one gives you P equal to B plus Z gives you 2Z. P perimeter is equal to breadth is of course 3.6. That's 3.6 plus 2 into what Z? Of course, Z is what there? Z. Okay, Z is what? 2.68. So in essence, perimeter will be equal to, if I work on this all together, I should have that P should be equal in value to 8.96. 8.96, of course, in meters. So I've gotten my area, I have gotten my perimeter. Why am I looking for area and perimeter? The reason why I'm looking for area and perimeter is to get your R, which is hydraulic radius. Let's get R from here. So I'll take this man down. So just take this part down. All right. So I don't need this diagram again. I'll take this off. Take this man off. So from here, I can see now, hence, R that we said is area over perimeter will be equal to what's area? That's 7.2. 7.2 over what's perimeter? Of course, that's 8.89. 96 per se. Divide these two. R will be equal in value to 0.804, of course, in meters. So I've gotten R. The main reason why I'm looking for R is to get V. You know, in V, we have C root RS naught. C is given, S naught is given. The only thing that's not given is R, and I've gotten my R. So I can proceed to get my V. All right, from here, but we said V equal to what? C root RS naught. I can get V now. How? R is already known. I know C, I know S naught. So put in values. What do you get? Let's get V. Let's get V. From here, V is equal to C is what? 49. The square root of R, we said R is what? Sorry, R is this man, that's 0.804 in brackets into S naught, that's 0 point something. When we did S naught there, we had 0 point, that's 0.00625. S naught is given from the question already, right? Work on this one here. V is equal to 49 into the square root of, multiply these two values together, you have about 0.0005025. These two together gives you this. From here, gives you V is equal to 49 times root of this value gives you about 0.0224. Finally, my V in this case will be equal to 1.098 meter per second. So I've gotten V. So the main task was to get Q, discharge. So from here, after gotten V, I can easily get discharge. So let's get the value of Q. All right, let's get Q, please. From here, we said that Q is equal to AV. All right, Q is equal to, what's A? We said A is 7.2, that's 7.2 times, what's V? 1.098. Combine these two together, of course, Q is equal to, multiply these two, that gives you 7.906 meter cube per second. That's discharge. So discharge is a meter cube per second. So this is how you find the discharge in this open trapezium channel. So this is how you get this concept is. So this is how you solve problems involved under hydraulics and hydrology. If you found this class helpful, don't to like this video, share to your friends and classmates, and also do well to subscribe to my YouTube channel. See you guys in the next class, and welcome to Excellent Link Academy.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. I just launched my website www.ganabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM students, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It's of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the under level itself. So do well to join this membership to support our online academic session. See you guys sooner.